Hello students, welcome to online lecture series of human-computer interaction. Now, today we are moving to our last unit, that is the future trends. Right? So today we will cover what is this ubiquitous computing, what are the different challenges of this ubiquitous computing, or what different challenges are faced by this technology. Again, next we will see what is this design thinking, why this design thinking is important. Also, there are different stages of design thinking. So we'll describe these 5 stages of this design thinking. Now we'll see one by one. Ubiquitous computing. So rather than enforce the user to search out and find the computer interface, ubiquitous computing processes that the interface can take on liability of locating and serving the user. Ubiquitous computing is the attempt to break away from the traditional desktop interaction model and move computational power into the environment that surrounds the user. So what is this ubiquitous computing technology? The general working definition is any computing technology that permits human interaction away from a single workstation. This consists of pen-based technology, handheld or we can say portable devices, large-scale interactive screens, wireless networking infrastructure, and voice or vision technology. Realizing the human-centered vision of Ubicom with this technology presents many challenges. Generally, but here he will focus on basically 3 challenges. First, defining the appropriate physical interaction. Second, discovering the general application feature. And third one is the theories of designing and evaluating the human experience within a Ubicom. So we'll see one by one. So defining the appropriate physical interaction experience. So here this ubiquitous computing inspired the application development, that is of the desktop. These visions assume that physical interaction between the humans and calculation will be less like the existing desktop keywords or mouse or display paradigms, and more like the ways human interrelation with the physical world. Human speaks, gesture, and use writing implements to communicate with other humans and alter the feature, we can say alter the physical artifacts. So in defining this appropriate physical interaction experience, so here you have to study what is this towards implicit input, towards multi-scale and distributed output, and the seamless integration of physical and virtual worlds. So this first towards implicit input. So input has moved beyond the precise nature of the textual input from keyboards and selection from a pointing device to the superior variety of the data types. Implicit input means what? This implicit input means that our usual interaction with physical environment provide adequate input to the variety of attendant services without any further user interference. This recognition technology are some examples of interpreting meaning from sense signal of the human activity. Second, towards multi-scale and distributed output. So this toward multi-scale and distributed output. So in incorporation of ubiquitous computing capabilities into the everyday life also requires a novel output technology and techniques. Output is no longer completely in the form of a self-contained desktop or laptop visual displays that demand our attentions. A variety of size or scales of visual displays, both smaller and larger than the desktop, are being distributed throughout the environments. The trend towards peripheral output has been explored from can say for a particular class of a displays called ambient. This ambient display need a minimal attention and cognitive effort and are a more easily integrated into a persistent physical space. One of the first ambient displays, the dangling string. So in this dangling string shares the many features with successive efforts in ambient display. The data resource derives the conceptual representation such that output can be monitored by the user peripheral perceptions. The next, seamless integration of physical and virtual worlds. So this seamless integration of physical and virtual worlds, the essential feature of Ubiquitous technology is that it attempts to combine computational artifacts smoothly with the world of physical artifacts. So researchers have suggested methods for using the object in the physical world to manipulate the electronics object, creating so-called graspable or tangible user interface. Sensors attached to device themselves provide ways of physical manipulations of those devices to be interpreted appropriately by the application running on those devices. Then, second, application theme for the Ubiquitous. Second challenge is that is application theme for Ubiquitous. So here the context-aware computing demonstrates the promise of making our interaction with the services more seamless and less distracting from our everyday activities. Application can be made to just work right when they are informed about the context of their use. Another feature of many Ubiquitous application is the ability of easily capture and store memories of a live experience and provide them up for a later use. The following section discusses two established things, that is context-aware computing, and second one, that is automated capture access. So is context-aware computing, that is when, what, and why. So location identifies the entity is a very regular piece of context used in Ubiquitous application development. The main general applications have been a GPS-based car navigation system and handheld tour guide system that differs the content displayed by the handheld unit given the user's physical location in an exhibit area. There is a more to context than a position, that is where, and identify, that is who. Although a full definition of a context remains an elusive research challenge, it is clear that addition of who and where context awareness involves. First, that is when, next what, and why. So when, with the exception of with the time as an index into a capture record, or summarizing how long a person has been at a particular location. Most context-driven applications are unaware of the passing of a time. What a way of interpreting the what of context is to see it as the focus of attention of one or more people during the live event. Knowledge of focus of attention at the live event can inform a better capture of that event. Why even more challenging is than pursuing what a person is doing is understanding why they are doing it. Sensing other ways of contextual data could give indications of person's affective state. There are several indoor position schemes as well as with the conflicting characteristics in terms of cost, range, granularity, and requirements for tagging, and no particular solution is likely to ever meet all requirements. Then automated capture and access. So this automated capture and access is a task of pursuing a record of live experience that is then assessed at some point in the future. Many researchers have worked towards this vision. As a result, many systems have been built to capture and access the practices in classroom, meetings, and other live experiences. Then towards continuous interaction. So provide constant interaction moves computing from localized tool to a regular presence. Common of a computer application support well-defined tasks that have a mark beginning and end with a multiple subtasks in between. Take a word processing as an example. Word processing features are adjusted for starting with a blank document, entering a text, formatting, printing, and saving. The importance of designing for continuously available interaction needs addressing these features of informal daily activities. So what are these daily activities? They hardly have a clear start or end. So design cannot assume a common starting point or a closure, requiring greater flexibility and simplicity. Interruption is accepted as users switch attention between the competing concerns. Multiple activities operate concurrently and may need to be loosely coordinated. Time is important, a discriminator in characterizing ongoing relationship between people and a computer. Associative models of information are needed as information is reused from the multiple perspectives. Then third is understanding the interaction in Ubiquitous. So that is understanding the interaction means here knowledge in the world, activity theory, situated actions, and distributed cognition. So here, as the computer has increasingly reached out in organization, researchers have needed to shift their focus from single machine engaging with an individual to a broader set of organization and social arrangement and cooperative interaction inherent in this arrangement. So many of these models and methods are applicable to Ubiquitous with emphasis on integrating numerous devices on one setting. So knowledge in the world, as the use of a computers has broadened, designers have moved to models that consider the nature of the association between internal cognitive process and outside the world. Designing for equilibrium between knowledge in the world versus knowledge in the head is now common axioms in the design community. Three main theories that focus on the in the world nature of knowledge are being explored within the Ubiquitous community as guides for future design and evaluation. Activity theory, situated actions, and distributed cognition. So activity theory. Activity theory also highlights the transformation properties of artifacts that implicitly carry knowledge and transitions such as musical instruments, cars, and other tools. Ubiquitous computing efforts informed by activity theory, therefore, focus on the transformational properties of artifacts and fluid execution of the actions and operations, situated actions, and distributed cognition. So here, situated action emphasize the improvisational facets of human behavior and de-emphasize a priori plans that simply executed by the person. In this method, knowledge in the world frequently shapes the ongoing interpretation and execution of a task. A distributed cognition also de-emphasizes the internal domain cognitions, but in this case, it turns to a system perspective where the humans are just a part of a larger system of all three theories. Distributed cognition play a greatest attention to knowledge in the world as much of the information required to accomplish a system is encoded in the individual projects. Then fourth is evaluation challenges for this UBICOM. So in evaluation challenges, the formative and summative evaluation of UBICOM system is hard and represents a real challenges for the UBICOM community. It is not clear that all the measures can apply universally across activities when we move away from a structured and paid work to the other activities. Shift away from the work of shift away from the world of work means that there is still questions of how to apply the qualitative or a quantitative evaluation methods. Technology used to create a UBICOM system is often on a cutting edge, and it is difficult to create a reliable and robust system that supports some activity on the continuous basis. So this is your some ubiquitous computing, right? Generally, in exam question asked like this. So explain the ubiquitous computing. So you have to explain this all the points related with this ubiquitous computing. In next lecture, we'll see what is the design thinking. What are the 5 stages of design thinking? Okay.